Hello dear students, this is Vijayalakshmi. Welcome to WinMaths YouTube channel. Here in this session we have to discuss the model question paper for second PUC Mathematics 2024 and 25. Here in this question paper we have to first check the weightage or framework for model question paper. Otherwise it is also called as a blueprint. Here from there are totally 13 chapters. Here based on these chapters, the model question paper will be ready. Total time duration for the solving this question paper will be 3 hours. Maximum marks will be 80 marks. First, have to instruction. Read the instruction now. The question paper containing 5 parts, namely A, B, C, and D. Okay, all parts should be compulsory. So you have to solve all the parts. Then part A has a 15 model question. Sorry, multiple choice questions and 5 fill in blank questions. Each questions carries 1 mark. Then third one, use the graph sheet for question on linear programming part E. Okay, have to use the graph sheet for part E question, that is linear programming question only. Then for questions having figure or graph, alternate questions are given at the end of question paper in separate section for usually challenged students only, not everybody. The alternate questions are given for only individually challenged students. Otherwise, all questions are compulsory for everyone. Okay, we can solve now the part A. Answer all the multiple choice question. The first question, that is, let the relation R in the set A is equals to X belongs to set of integers 0 which is less than or is equals to X, less than or is equals to 12. Given by, there is a relation R, the pair A comma B such that the elements A minus B, mod of A minus B is multiple of 4. Then the class 3, the equivalence containing 3 is. Okay, here first have to consider the set A. Here first have to consider the set A. I can write the elements of set A. That is, A is equals to elements 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. We can define a relation. Okay, what is that? If whatever the elements A, B taken, then the modulus of A minus B must be a multiple of 4. Here, the pair 0 minus 3, it is not given. Okay, 0 comma 4. 0 minus 4, we get 4. This is the multiple of 4. Similarly, 1 comma 5. Okay, 1 comma 5. Then 2 comma 6. Again 3 comma 7. Next 4 comma 8. 5 comma 9. 6 comma 10. Otherwise, no. Here, okay, 7. 7 comma 11 and the last one 8 comma 12. Okay, 0 minus all times we get 4. Then again I can take here 0 comma 8. 0 comma 8 we get 8. This is also multiple of 4. Then 1 comma 9, again 1 comma 9, again 2 comma 10, 3 comma 11 and 4 comma 12. These are the pairs. And last one 0 comma 12. Here 0 comma 12. That is 0 minus 12 we get 12 only. And also every element has 0. Okay, the set containing 0, comma 0, this is also multiple 1, comma 1, 0, which is the multiple of 4 up to so on for 12, comma 12. These are the set of relations. Okay, but we want the equivalence class containing 3. We want the equivalence class containing 3. It means when? It means when we take the values. Okay, here it means whatever the values we have to taken for B. Otherwise, A. One value should be, the pair should be 3 only. Here we have to find the equivalence class of 3. A must be 3. Then have to take the values. B will be changes. When we got the multiple of 3, 3 minus 7. Okay. Therefore, 3 is the element. 3 minus 3, 0. We get equivalence. Again 3 comma 7. 3 minus 7, 4. This is also multiple of element. And again 9. 3 comma 11. Okay, 11 minus 3, we got 8. Okay, 11 minus 3, we got 8. Then it is also multiple of 3. I can write here 3 minus 3. Modulus of 3 minus 3, we can get 0. Then 7 minus 3, we get 4. 11 minus 3, we get 8. These are the multiple of 4s. These are the multiple of 4. Therefore, what are the elements of B? 3, 7, 11. The option D will be the right answer. Option D will be the right answer. Okay, let's move on the next one problem. Question number 2. If cot inverse of x is equals to y. Okay, here cot inverse of x is equals to y, then we have to find the range. That is, we know that cot inverse of x is equals to y, containing the domain open interval 0, comma 5. Okay, open interval means have it contain strictly conditions, that is 0 is less than y less than 5. Therefore, the option 2 is correct. The option 2 is correct. Next, move on the next question. Question number 3. If Aij is a symmetric matrix, already know that the definition of symmetric matrix, that is A is equals to A transpose. Okay, the definition of symmetric matrix means A is equals to A transpose. The elements are written, both are equal. Here I am generally taking the elements Aij. Okay, transpose of this matrix. While taking the transpose, the rows and columns are interchanged. That is Ji. Okay. Here Aij is equals to Aj. The symmetric matrix of order m cross n. If before going that, the symmetric matrix must and should be a square. Okay. It should be a square matrix. It means m is equals to n. The order must be a equal. Therefore, first condition symmetric matrix is said order equal. Then the elements Aij is equals to Aji. The option number 2 is right. Here also same. Option C is also same. But here the order not mentioned. Okay. Order not mentioned. That's why the suitable answer will be option number B. Let's move on the next problem. Question number 4. Here they given determinant, have to find the value of x. We already know that the for finding the value of determinant, I can take the left hand here, LHS part, that is limit of 3x x 1. No, I can solve 3 into 1 3. x into x square minus x square. So again, RHS part I can solve. That is 3, 2, 4, 1. We get 3 into 1, 3, 4 to the 8. Now, both LHS and RHS are equal. I can solve here. That is 3 minus x square is equals to 3 minus 8. 3 get cancelled. Minus minus get cancelled. That is x square is equals to 8. So x is equals to root 8. The option does not containing root 8. So I can simplify here. Now I can write 8 as 2 into 2 into 2. This is square. That's why square root I can take both 2. That is 2 into root 2. The values square means the values are plus or minus. There is a 2 values. So the option number 4 will be the right answer. Okay. Let's move on the next questions. Question number 5. First statement, left hand derivative of f of x. Here I can solve left hand derivative of f of x. Here we know that the definition of derivative. Okay, what is that? F dash of x can be written as limit x tends to a f of x plus h minus f of x divided by h. This is the definition of the derivative function. Okay, here I can take the first statement, left hand derivative. Here we have to check the left hand derivative for f of x is equals to mod x. Okay, now I can take left hand limit, left hand derivative, that is f dash of x only, x is equals to at x is equals to 0. In place of a, I can take x tends to 0 minus, because we have left hand limit f of, in place of x we have 0, 0 minus h. For left hand limit, I can take minus f of 0 divided by h. No, 0 minus h. By the definition, 0 minus h, that is minus h f of 0 divided by h only. Again, I can take f of minus h. Okay, mod of, for left hand limit, the function mod h, that is mod of minus h divided by mod of 0, 0 only divided by h. So mod of, for left hand limit, mod of minus h will be again minus h divided by h. H by h is equals to minus 1. We have the value minus 1. They are also given left hand derivative of f of x of mod x at x is equals to 0 is minus 1. We have same result. Therefore, the statement 1 is true. Again, we have to consider the left hand limit derivative of f of x at x is equals to a. Limit h tends to 0, f of a minus h. The question will be this is the incorrect statement. Okay, what is that? The function, the derivative f dash of x is equals to limit h tends to 0, f of a minus h is incorrect statement. This is the incorrect statement. Okay, we can't write the derivative. Therefore, this is the false statement. Okay, statement 1 is true, statement 2 is false. So, we can check the option now. Statement 1 is true and statement 2 is false. This is the right answer. Okay, the option is true. Again, next, question number 6. Okay, here question number 6. the derivative of log of sec x plus tan x with respect to x. So we can find the derivative. Let us consider the given function y is equals to log of sec x plus tan x. Okay, we know that. Before going to that, we know the differentiation of log function. What is the differentiation of log x will be? 1 by x. That is, differentiation of log x will be 1 by x. Similar property I have applied, differentiation with respect to x only, with and differentiate with respect to x. So this one is y dash. Again, I can take whole thing as a x. Therefore, log x will be 1 divided by x. In place of x, what is this? Sec x plus tan x. In place of x, we have sec x plus tan x. That's why I can again differentiate d by dx of sec x plus tan x. D by dx of sec x plus tan x. Again, I can differentiate 1 divided by sec x plus tan x into. Here there is a plus, so I can separately differentiate. That is d by dx of sec x plus d by dx of tan x. Now I can differentiate separately 1 by sec x plus tan x into. Here, differentiation of sec x, that is sec x into tan x. Differentiation of sec x will be sec x into tan x, again plus differentiation of tan x will be sec square x. Okay, this is the result. But in option, there is no options here. Okay, so we have to simplify the result. First, here in this sec x into tan x plus sec square x, I can take sec x as a common. So sec x is a common remaining. In place of sec x, I can take sec x. There is a tan x will be there. Tan x plus here one sec x I will taken out. Another sec x will remaining divided by what is that? Sec x plus tan x. Sec x plus tan x. This sec x tan x and tan x plus sec x will get cancelled. We have the result sec x. This is the result. So option number 1 will be the correct answer for the derivative of log of sec x plus tan x with respect to x is sec x. Let's move on the next one problem. Okay. Find the absolute maximum value of the function f is given by f of x is equals to x cube for every x is belongs to the open interval minus 2, close interval minus 2 comma 2 is. Okay, now we have to find the absolute maximum. The condition for finding the absolute maximum here, first have to differentiate once. For finding the absolute maximum value, have to find the differentiation first. After finding the differentiation, have to, okay, here first have to take the function f of x is equals to x cube. We can differentiate with respect to x. Okay, now I can differentiate f dash of x is equals to 3x square. Now take f dash of x is 0. That is f dash of x is equals to 0. So we have taken this one 0. That is 3x square will be 0. Find the value of x here. X square is equals to taking 3 on this one. It becomes 0. Therefore, x is equals to 0. Now, again have to take x as a endpoints. One point will be taken from the differentiation, and while taking another two endpoints as a x, that is minus 2 comma 2. Now have to substitute these value in the function. Okay, that is f of x. F of 0. What is the x cube? 0 cube will be 0. Now, check. For 2, 2 cube, that is 8. Now, for minus 2, that is minus 2 cube. Minus 2 into minus 2 into minus 2, it becomes minus 8. This is the maximum value and this is the minimum. Okay. So, absolute maximum value of the given function is 8. That is option number 4. Therefore, absolute maximum value of the function f is given by f of x is equals to x cube is 8. So, have to find the first differentiation, then taking differentiation equals to 0. So, have to find the value of x, and again we have to take the endpoints also. So, have all the points are substitute in the function, then we have get the maximum and minimum. That values are the absolute maximum and absolute minimum values. Then question number 8. Okay. Next, the point of inflection for the following graph. Have to observe the following graph. Okay. Here, the point of inflection. Okay. When we can observe. Okay. The point of inflection means where the point, the middle point, which is the graph will increase from downwards to upward. The middle point of graph is called the point of inflection. Here, the point of inflection is 0. Okay. Here, the point of inflection, option number C, will be 0. Here, in this point, at point of 0, at this point, the graph will be increases from decreases to increases. Therefore, here at point of minus pi by 2, the graph will be downwards. Again, at point pi by 2, the graph will be increasing. Okay. So, in that point, the middle point of increasing and decreasing graph is called the point of inflection. Therefore, the point of inflection for the graph is 0. Okay. Next one, the question number 9. Here, integration of ex into 1 by x minus 1 by x square into dx. We know that the one important property, that is on exponent function. Integration of e to the power x of f of x plus f dash of x dx is equals to integration of x f of x plus c. This is one of the important function or formula. Okay, this is the one of the important result, that is integration of e to the power x into f of x plus f dash of x dx is equals to e to the power x f of x plus c. Here we can observe. Okay, here in that function I can take f of x as a 1 by x. Okay, here f of x as a 1 by x. Now I can differentiate, and f of x, differentiation of 1 by x, that is minus 1 by x square. Okay, here this is f of x and this is derivative of the f of x. Therefore, by applying the standard result of the integration of exponential function, so I can write the differentiation or integration of e to the power x will be, the result will be e to the power x f of x. What is the f of x will be? 1 by x plus c. Okay, that is e to the power x into 1 by x plus c. Now, let's see the option here. Okay, let's see the option. Which option is suitable? That is option number C. Okay, option e to the power x divided by 1 by x plus c. This is the correct result of the given problem. Next one question. Question number 10. Integration of x into sin x. Here there are two functions are there. One is f of x and another one is g of x. Okay. This is of the form integration by parts. Integration by parts. Integration by parts. It means there are two functions they given for integration. So I can use one rule, that is Eilert rule. Based on Eilert rule, I can solve the integration. What do you mean by the Eilert? Eilert means have to take first function, that is f of x as a, here f of x and g of x, have to check the first function and taking second function. Now I can take first function and second function. That is I means inverse trigonometric. First preference for inverse trigonometric, second preference for logarithmic function, and third preference algebraic function, fourth preference trigonometry, and last preference exponential. Based on the preference, we have to solve the problem easily. Okay. Here I can take preference. Based on the preference, I can solve the problem. Based on the preference, I can solve the problem here. First preference for by this one, here there are first one algebraic function, here trigonometric function. So I can take first preference for algebraic question and second preference trigonometric. Based on the preference, we can use the formula here. Integration x into sin x. So first have to take the first function as a constant, take second function as a integration. That is sin x minus take second double time integration for second function and differentiate the first function, that is x. The general formula here, based on the preference here, first function constant integration of second function minus double integration of second function and derivative of first function. Okay, this is the general rule for solving the integration by parts. Okay, now I can solve here. That is x is a common integration of sin x. As we know, the result of integration of sin x, that is minus cos x. Minus of, again, integration of sin x will be minus cos x and another integration remains same, and differentiation of x with respect to x is 1. Therefore, x into minus cos x, that is x minus cos x. I can take minus as a common. Minus into minus will be plus integration of cos x into dx. Here, minus x cos x plus integration of cos x will be sin x plus c. This is the result of the given problem. Okay, let's observe the options here. Okay, we have the result minus x cos x plus sin x plus c. So I can observe the option here. Now minus x cos x minus here there is a plus, so nothing. Here minus not there. Here minus x, this is also not. Here only minus cos x now. But all options are wrong. This is may grace marks will be for this question. So nearest answer will be the option number A. Here there is a 1 plus changer. So this will be grace marks for you. Now sometimes happens, but concept will be perfect. Now let's move on the next one problem. Question number 10. The projection vector of the vector AB on the directed line I, directed line L, if angle theta is equals to pi by 2 will be. Mummy, speaker commute go. Okay, let's consider the next one problem. That is question number 11. The projection vector of the vector AB on the directed line L if angle theta is equals to pi by 2 will be. Okay. Here, first have to consider the definition of projection vector. Okay. That is projection vector of AB is magnitude of vector AB into cos theta. Here for magnitude of AB is taken the given angle theta. Angle theta is equals to pi by 2. I can apply here cos pi by 2. What is the value of cos pi by 2? That is 0. That is, what is that? Cos 90. Pi by 2 is 90. Cos 90 will be 0. So 0 into anything will be 0. Into 0. 0 into anything will be 0. Therefore, the projection vector of AB is 0 vector. The option number A is correct. Let's move on the next one question. That is question number 12. For the given figure, vector P minus vector Q. Here there is a subtraction vectors. Okay. As per definition or figure, I can write vector P. This is from O to A. That is O to A vector minus Q O to B vector OB. Next, we know that the law of vector addition of parallelogram, I can write OA minus OB can be written as a vector BA. Okay, here vector B, OA, vector OA minus vector OB can be written as by using the law of parallelogram, that is BA, vector BA. The option number C is correct. Next, question number 30. Okay. The direction cosines of negative z-axis. First, we know that the direction cosines. Okay. I can write the direction cosines here. That is cos alpha is equals to cos beta is equals to cos gamma. Here I can take the axis. Sorry. I can draw here. Simply, I can draw a diagram here, rough diagram. This shows the x-axis, y-axis and z-axis. Here there is a negative angle. Okay. There is upward side is the positive angle, downward as a negative angle. From this one to this, negative angle shows the 120 degree. Axis to y-axis will be the 90 degree and this is the 90 degree. So I can take the values here, that is cos 90 degree on y-axis, that is beta, cos 120 degree for z-axis. Negative axis, it shows the 120 degree. By the applying the values here, cos 90 will be 0. Here also 0. This is minus 1. So the direction cosines are 0, 0, minus 1. The option number B. Okay. Next one question. Question number 14. That is based on probability. If probability of A is equals to 1 by 2, probability of B is equals to 0, then probability of, this is the conditional probability. Already we know that the property of the conditional probability, probability of A on B. Okay, probability of A on B means have to write probability of A intersection B divided by probability of B. Simply we can remember the formula. What is that? Probability of AB. Okay. So first have to write the intersection, probability of A intersection B here on B. Okay. So I can write divide by B. So I can substitute the values here. Probability of A intersection B not given. So but we know that the property when the two probabilities are mutually exclusive or independent. That time probability of A into probability of B is equals to probability of A intersection B. By this property, I can write that probability of A intersection B is, what is the probability of A? 1 by 2 into probability of B, 0. What is that? 0. Therefore, probability of A intersection B will be 0. I can apply here. Again, what is the probability of B? They given probability of 0. That is, probability of A on B is 0 by 0 form, which is not defined. Therefore, the option B is correct. The probability not defined. Next, question number 15. Okay. Here, an urn contains 10 black and 5 white balls. Okay. Here, there are totally 15 balls. Okay. Black balls are 10 and white balls are 5. Total number of balls are 15. It means the sample space is 15. An urn contains 10 black balls and 5 white blocks. We have to draw 2 balls, one after the other without replacement. Then probability of both drawn balls are black. Here we can select both are black. Okay. Here both balls are black. So total number of balls. Totally 15 number of balls. When we select one ball out of 15 balls, first ball should be a black. How many chances? 10 chances. Because there are 10 black balls, there are 10 chances. Next, this is the first ball should be black. And again, I can draw second ball also is black. Second ball also black. Already here one ball are taken out. Then how many ball left? 14. Okay. Again, here out of 14 balls, we want second ball also black. So here already one black balls taken out. Remaining will be out of 9. There will be a one black. Okay. This is the probability. Now we can simplify now here. 10 into 5 is a, okay, 5 2 is a 10, 5 3 is a 15. Again, 3 1s are 3 3s are 2 1s are 2 7s are. In upward denominator, there is a numerator 3, denominator is 7. Therefore, the probability of getting two black balls is 3 by 7. This is the option number 5. This is the result. Okay. To this much, the multiple questions will be done. Okay. Let's move on the fill in blanks. Then fill in the blanks by choosing the appropriate answer from those given in the bracket. Okay. Here out of 6 values, we can substitute. Okay, choose which one is suitable for that question. Okay, next question number 16. The number of points in a R for which the function f of x is f of x plus f of x is equals to mod x plus mod of x plus 1 is not differentiable. The function is not differentiable at how many number of points? Okay, the function is not differentiable. For how many points on that points, the function is not differentiable. So, first I can take f of x. Okay, here f of x is equals to mod x plus x plus 1. Okay, I can take at x is equals to 0. Okay, here I am taking x is equals to 0. The value becomes 0. Here there is a 1. Okay, I can check the function is differentiable or not at x is equals to 0. Here I can take x as a 0. The function is 0. Again, at x is equals to here, I can take x as a minus 1. There are 2 points. Okay. Here there are one is directly I am taking x as a 0. Here in this condition I am taking x is equals to minus 1. For these two conditions I can differentiate. Okay. Whether function is differentiable or not. First, I can take the function as a differentiable. So here there is a modulus function. I can use right hand limit and left hand limit. Okay. That is let for mod x. Let the function f dash of x is limit x tends to 0 minus f of x is f of 0 plus x minus f of 0 divided by x. That is, here I can take left hand limit. This is minus. Okay. We have f of 0 minus x. That is f of minus x, f of 0 divided by x. F of minus x will be minus 1. Again, I can take the right hand limit f dash of x. That is equals to limit x tends to 0 plus. So, f of 0 plus h minus f of 0 divided by x. Done. F of, sorry, here x. F of x minus f of 0 divided by x. Like this is x by x. Here the left hand limit and right hand limit are not equal. The function is not differentiable at x is equals to 0. Similarly, I can take the at point x is equals to minus 1. Okay, that is f dash of minus 1. That is limit x tends to minus 1 of minus. Here also I am taking f of 0. Here minus of 1. F of 1. Simply I can take, there is a 1. The value becomes again 1 by 1. I can take 1. For right hand limit f dash of minus 1, I can take limit x tends to minus 1 comma plus f of 0 minus 1 minus of f of 1 divided by 1. I can get minus 1. Here the left hand limit will be 1, right hand limit minus 1. The function is also not differentiable. Therefore, there are 2 points. Okay, the number of points in R is there are 2 points. For this point, the function is not differentiable. Therefore, the number of points in R, which is the function, the answer is 2. Okay, the answer is 2. For the first one, question number 17. The value of I dot j cross k minus j dot k cross I minus k dot j cross I is. Here, we know the results of cross product as well as dot product of vectors. That is I cap dot I cap is equals to j cap dot j cap, k cap dot k cap is equals to 1. Okay, like products are equals to 1, but unlikes are 0. I dot j, j dot k and k dot I. These are equals to 0. Similarly, we know that the cross product. While taking the cross product on like this is I, j and k. From move here, the products will be move on from clockwise, clockwise direction I to j. That is I cross j is k. J cross k. J cross k is I and k cross I is j. Okay. The direction move on from clockwise direction. If anti-clockwise direction move on, the values becomes negative. That is j cross I will be minus k. K cross j will be minus I and I cross k is minus j. By using these results, apply here. Okay, I can solve now. I cap dot here j cross k. J cross k is again I cap minus j cap dot k cross I. K cross I is j minus again k. K cap into j cross I. J cross I is minus k cap. Now, I dot into I dot 1 minus j dot into j dot, that is minus, here minus and minus will be plus k dot k, that is 1. Plus 1 minus 1 get cancelled. We have the result 1. Okay. Let's move on the next one. Here there is a 2, 1. The sum of the order and degree of differentiable equation. Here they given differential equation. First have to check the order. Okay. Here dy by dx, already we know that dy by dx is the first order differentiable. D square x divided by dy square is the second order differentiation. Therefore, order is the highest order in that equation is second order, that is 2. Have to check the degree. Okay, have to check the degree for which one is the higher order. Okay, which one is the higher order, we have to check the degree. Power of the higher order will be the degree. Here the power of this second order will be 1. Therefore, degree is 1. They given sum of the order and degree. So we have to add these two. 2 plus 1 is 3. The answer will be 3. Okay. Let's move on the next one problem. Okay, question number 19. The total revenue in rupees received from the sale of X unit of product is given by R of X is 2x square minus 4x plus 5 the marginal revenue when x is equals to 2. So first I can consider r of x is equals to 2x square minus 4x plus 5. We can differentiate r dash of x is equals to 4x minus 4. Now at x is equals to 2. So substitute here r dash of 2 is equals to 4 into whenever x have to substitute 2. 4 into 2 minus 4. That is 4 2s are 8. 8 minus 4. It becomes 4. The value becomes 4. Okay. Let's move on the next one. Here there are 2 points. The value becomes 1 and here there is a 3. This one value becomes 4. Then question number 20. If probability of A is 3 by K, probability of A intersection B is equals to 2 by 5 and probability of conditional probability B on A, that is 2 by 3, we have to find the value of K. We know that the definition. Okay. What is that? Probability of B on A. Already I am saying the property. Probability of B on A means have to write first intersection. A intersection B divided by, here there is a B on A. So I can take probability of A. Now probability of A intersection B, that is 2 by 5 whole divided by probability of A, that is 3 by K, and here probability of B on A is 2 by 3. Simply I am written here this one as 2 by 3 is equals to 2 by 5. By the property I can take multiplication and here it becomes K divided by 3. Okay. Now 2 get cancelled. Here 3 get cancelled. There is a 1 left here. 1 is equals to A by 5. I can take 5 on left side. 5 is equals to K. Therefore, A value becomes 5. Okay. Up to this much, the filling blanks questions will be completed. Let's move on the part B. Okay. Let's move on the part B. Here there are compulsory. You have to write the 6 questions. Have to write the 6 questions. There is a first one question. Show that sine inverse of 2x into root of 1 minus x square is equals to 2 sine inverse of x. First, I know I can consider here this one is. So have to observe the LHS part and RHS part. So here you can take, we want 2 into sine inverse of x. That's why first I am taking LHS part, that is sine inverse of 2x 1 minus x square. Okay. Here I can take sine inverse of x is equals to theta. Then taking sine inverse on right side, it becomes sine theta. In this LHS part, wherever x, I can substitute as a sine theta. That is sine inverse of into sine theta into root of 1 minus sine square theta. Again, sine inverse of 2 sine theta into, we know that 1 minus of sine square. Already we know the formula for identities, trigonometric identities. That is sine inverse of, Sin square x plus cos square x is equals to 1. Okay. By applying, we want 1 minus sin square theta here. That is, I can take this one as a, that is cos square x here. Taking sin square x on right side, it becomes 1 minus sin square x. Simply, I can replace 1 minus sin square x by cos square here. That is root of cos square theta. Root square get cancelled. We have sin inverse of 2 sin theta into cos theta. Already we know that the formula, that is sin 2 theta is equals to 2 sin theta and cos theta. I can apply here, that is sin inverse of sin 2 theta. We know the property of trigonometric function. Simply we can return to theta. What is the value of theta? That is 2 into sin inverse of x. This is the RHS part. Hence, this is the proof of the given problem. Okay. Let's move on the next one problem. Question number 22. Okay. Here, question number 22. Okay. Question number 22. That is, show that the points A, the points A containing A comma B plus C and B containing B comma C plus A and the point C containing C comma A plus B are collinear using the determinants. We know that the one of the result, the points are collinear, then the determinant becomes 0. The determinant value is 0. The points are collinear. The points are collinear. Okay. So I can show that the determinant value is 0. So first I can return the points. Determinant of here. Simply I am taking the determinant as a. The first point A comma B plus C. B point, that is B comma C plus A and C, that is A plus B. The last column will be taken as a 1. Then A is equals to, I can take the determinant, that is multiplication. First element plus minus plus A into, neglect the first column, first row, that is C plus A into 1, C plus A minus of A plus B into 1, A plus B minus second point B. So neglect the first column and second row, B into B plus C minus of here A plus B plus C into, neglect the first column, third row, B plus C minus of C plus A. Now here A into C plus A minus of A minus B minus B into B plus C minus A minus B plus C into B plus C minus A. I can take here A into plus A minus A get cancelled. C minus B of here plus B minus B get cancelled. We have C minus A plus C minus C get cancelled. We have B minus A. Now again multiplication AC minus BA minus BC minus into minus plus AB plus CB minus AC. Here plus AC minus AC get cancelled. Plus BA minus BA plus AB get cancelled. BC, CB get cancelled. We have 0. This is the solution of the given points. Therefore, the points A, B and C are collinear. C are collinear. This is the solution of the given problem. Let's move on the next one. Question number 23. Find dy by dx if 2x plus 3y is equals to sin x. Okay. Here they given differentiate with respect to x. First, I can considering the equation 2x plus 3y is equals to sin x. Okay. Now, I can take differentiate with respect to x. I can take differentiate with respect to x. Here 2 becomes constant. D by dx of x plus 3 into d by dx of y is equals to d by dx of sin x. Now, 2 into differentiation of x with respect to x is 1 plus 3 into dy by dx is equals to differentiation of sin x. It becomes cos x. We want dy by dx. So, I can take 3 dy by dx here. Taking plus 2 on right side, it becomes cos x minus 2. We want dy by dx. Dy by dx is equals to cos x minus 2 divided by 3. This is the solution of the given problem. Let's move on the question number 24. Find the local maximum value of the given function. Okay. Here finding the local maximum value of the given function. First, have to consider the function, that is g of x is equals to x cube minus 3x. Have to check the first question. Dy by dx gx is equals to x cube minus 3x. Now differentiate with respect to x. Okay. First, differentiate with respect to x. G of x is equals to 3x square minus 3. Now again, differentiate another one time. That is g double dash of x is equals to, again I can take differentiation 3 as a constant. Differentiation of x square will be 2x. Again this differentiation of 3 will be 0. It becomes 6x. Now I can take g dash of x is equals to 0. Okay. G dash of x is equals to 0 for maxima or minima. For maxima and minima. Now I have to find the values of x here, the points of x. So g dash of x is equals to 0. Then 3x square minus 3 is equals to 0. taking 3x square here, plus minus taken here, it becomes plus 3 on right side, 3 get cancelled, x square is equals to 1, x has the two values, one is plus 1 and here minus 1. For these values of x plus 1 and minus 1, we can check here, that is for x is equals to 1, g double dash of x is, what is that? 6 into 1 become 6, which is greater than 0. Again, for x is equals to minus 1, I can take g dash of x is equals to 6 into minus 1, here minus 6. This is less than 0. Therefore, by the definition of the local maxima, g double dash of x is less than 0, then it is the local maxima. It is the local maxima. It is the local maxima. Okay. Therefore, this is the local maximum of the given function. Therefore, local maximum value of the maximum value of given function is minus 6. Okay, this is the local maximum value is minus 6 at number 25. Here we know that the result of sin 3x and cos 4x. Here by the trigonometric relation I can simply written as sin 3x. I can simply written sin 3x as, that is sin A and sin A cos B is equals to 1 by 2 sin A plus B minus of sin A minus B. I know the result. Okay. By using this result, we can solve the integration. Here, I can write integration sin 3x as A and cos 4x as taken as B. By using the property, I can write 1 by 2 sin of A, that is 3x plus 4x minus sin of 3x minus 4x. Okay. Here I am taking 1 by 2 as a constant. Then taking integration sin 3x plus 4x, it becomes sin of 7x minus. Here sin of 3x minus 4x will be minus x. We know that property of trigonometrics, sin of negative theta, negative angle will be negative of sine angle. Okay. By using that result, I can written into dx. Here also dx integration of sin 7x minus sin, here taking minus, that is sin x into dx. I am taking integration separately. 1 by 2 integration of sin 7x dx plus integration of sin x dx. We get the result 1 by 2. Integration of sin x will be minus cos x. In place of x, we have 7x. So I can divide 7 here minus cos. Integration of sin x will be minus cos x plus some constant c. Therefore, 2 into 7, 14. It is minus cos 7x divided by 14 minus cos x plus, this is the solution of the integration sin 3x into cos 4x dx. Now, let's move on the next question. Question number 26. Find the general solution of the differentiable equation. Here, we know that the solution of the general solution. So, first I can consider problem y dx minus x dy divided by y is equals to 0. Here y is combined to both. So I can take separately y dx divided by y minus x divided by y. Here y get cancelled. We have x only minus x by y dy is equals to 0. Now I can take minus x divided by y dy on right side. It becomes x divided by y dy. So I have taken y on left side. It becomes y into dx is equals to x into dy. Now again I am taking x on one side and y on one side. Taking x on left side, it becomes divide 1 by x dx, and taking y on right side, it becomes 1 by y into dy. Now taking integration, here both sides, in the left side 1 by x with respect to x, here 1 by y with respect to y. This is the simplified form. Now here taking integration on both sides. Taking integration on both sides, that is 1 by x into dx is equals to integration 1 by y into dy. What is the integration of 1 by x dx will be log x is equals to integration of 1 by y dy will be log y plus, while taking the integration, taking some constant value as a c. Then I can take log x. We know that the property of law of indices, that is log m plus log n, can be written as log of mn. So I can simply written as log of mn as a log yc. Here by the property both log get cancelled. We have x is equals to yc. This is the general solution of the given differentiable equation. Next, move on the next one problem. Question number 27. Find the magnitude of x. Here, find the magnitude of x if for a unit vector a, x minus vector a dot vector x plus vector a is equals to 15. Now, I can consider vector x minus vector a, next vector x plus vector a. I can take dot product as a multiplication is equals to 15. Here, vector x into vector x will be magnitude of vector x square plus x into vector x into a, that is vector x in dot vector a minus vector x dot vector a. Again, we know that minus into plus into minus, it becomes minus vector a dot vector a. It becomes magnitude of vector a whole square is equals to 15. The dot product, taking here both are cancelled. That is vector x magnitude square minus vector a is equals to 15. Already in that question they given vector a becomes unit vector. Unit vector means vector a value becomes 1. So I can take here 1 magnitude of x square of vector x minus 1 is equals to 15. I can take minus 1 on right side. It becomes positive, that is 16. So I can written vector x square is equals to 16. We want magnitude of vector. So 60, taking root on here, let's say root 16. It becomes 4 plus or minus 4. Therefore, vector x is equals to plus or minus. This is the solution of the given problem. Next one, find the equation of the line in vector form that passes through the point with position vector 2i cap minus j cap plus 4k cap and is in the direction of I cap plus 2j cap minus k cap. Okay, here the equation of line in a vector form. We know that equation of line in vector form. Equation of line in a vector form is vector r is equals to vector a plus lambda into vector b. This is the equation of line in a vector form. So I can substitute the values here. What is the vector A? That is 2i minus j plus 4k. So I can take in here 2i minus j plus 4k plus of lambda into vector B. I cap plus 2j cap minus k cap. Now, taking the values here, 2 minus 2 I cap minus j cap plus 4k cap. I can multiply lambda on each values. Lambda I cap plus 2 lambda j cap plus minus lambda into k cap. In vector form, I can take I cap, j cap and k cap as a common factor. So written 2 plus 2. Here there is a lambda. Here there is a lambda. 2 plus lambda I cap minus 1. Here only j is there. So in there is a 1 present here. 1. Here 2 lambda minus 2 lambda. Already I am taking minus outside. That it becomes 1 minus 2 lambda j cap plus 4 minus lambda k cap. This is the equation of line in a vector form. Okay. Now let's move on the next one problem. Question number 29. Okay. Here the question is, prove that if E and F are independent events. Okay. Here E and F are independent events, then so are the events E and F dash. We already know that the two Independence. Okay. Independent event means the product of two events. For example, here E and F. Probability of E and probability of F is equals to probability of E intersection F. This is the definition of the independent event. Independent means product of two probabilities is always equals to intersection of their property. Okay. Here I can solve. Let us consider, since already they given E and F are independent events. E and F are independent events. E and F are independent events. Then, by the definition of independent events, we know that probability of E intersection F is equals to probability of E into probability of F. This is the main definition of independent event. Now, I can written here. Okay, we can written here probability of E. Okay, here I am taking one Venn diagram. By that Venn diagram, I can prove the result here. This roughly I am taking here. Roughly I am taking here. There is a here one. This one is the event E, and here this is the event E intersection F. E intersection E be an event, F be an enter. There is a common region is the probability of intersection F. From the diagram, we can say, from the diagram, we can simply written probability of E. Okay, I can written probability of E. The event E can be written as E minus, okay, E minus F dash. It means here F complement. Complement means other than F. Here there is event exist, a complete event containing the value E. It means only the event E. Again, this one shows the F. This one is E complement F. That means only containing F. Okay. By this one diagram, we can say E intersection of F, E intersection of F and E intersection F dash are mutually exclusive. Mutually exclusive. Mutually exclusive. It means mutually exclusive means there is no common element, that is E intersection F intersection of E inter complement of F are null. There is no common element between these. Here and this one, there is no common elements here. So I can written E intersection of N and E intersection of F complement are mutually inclusive. So I can written probability of E is equals to probability of E intersection F minus the plus probability of E intersection F complement. So we want E intersection F complement because they given E and F complement. I can take probability of E intersection F is equals to probability of E minus probability of E intersection F. By the definition of probability of E, I can written here by using the above definition. This I can take one. By using the equation 1, I can written probability of E into probability of F. Then taking probability of E common, then 1 minus probability of F. We know that the definition probability of E 1 minus F means complement. That is probability of F complement. Therefore, probability of E intersection F complement is also independent. This is multiplication probability of F complement. This is the proof of the given. Hence, we can say the events E and F complements are independent. Okay, up to this much, the question number part B. Up to this much, the part B is completed. Let's move on the part C. Okay, here part C, we have to solve the 6 questions. Here discuss the part C. Here answer any 6 question. Each question carries 3 marks. Okay. First one question. Show that the relation R in the set of real numbers are defined as A related to B such that A comma B such that A is less than B is reflexive and transitive but not symmetric. It means have to check the condition reflexive, transitive and symmetric. The relation holds the reflexive and transitive property but doesn't holds the symmetric property. Okay. Now let's start the problem. Let us consider let us consider the relation. That is R is equals to A comma B such that A is less than B. Now, first condition, I can check the reflexive property. Here, let 1 be a real number. I can take the values 1 comma 1. Here 1 comma 1, then the relation holds 1 comma 1 such that 1 is less than or is equals to 1. Okay, here there is two condition. One is less condition and another one is equal. So the condition will be holds for equality. 1 comma 1 is belongs 1 comma 1. 1 is less than or is equals to 1 only. Similarly, 2 is less than or is equals to 2 such that for every element of 2 which is belongs to real number, here also for every 1 is belongs to the real number. That is by the definition of reflexive, we can say A is less than or is equals to A such that A is belongs to real number. Therefore, A comma A belongs to R for every A is belongs to R. Hence, R is reflexive. Similarly, checking the second condition. Similarly, I can check the second condition. Here, let 2 comma 3 belongs to R, but 3 comma 2 does not belongs to R. Here I can check now. There is a relation R. Okay, that is 2 comma 3, such that 2 is always less than or is equals to 3. 2 is less than 3. The condition is holds. But 3 is not less than 2. 3 is not less than 2. This property does not holds. Simply I can written by definition, A comma B belongs to R, but B comma A does not belongs to R. Hence, R is symmetric. Similar to that of transitive condition. R is not symmetric. Similarly, I can check the transitive condition, that is transitive condition. Let 1 comma 2 belongs to R, then I can take 1 is less than or is equals to 2. Similarly, 2 comma 3 belongs to R. This is also holds the property 2 is less than or is equals to 3. Again, taking 1 comma 3. Okay, here the simplify that implies 1 comma 3 is also belongs to R. 1 is always less than 3. Okay, 1 is less than 3. This holds the transitive property. So I can write for every 1 for every 1 comma 2 comma 3 which is belongs to real number. Okay, by definition what we say, let A comma B belongs to R and B comma C belongs to R. That implies A comma C is also belongs to R. Hence the relation the relation is transitive. Now, by checking all the conditions, by checking all the conditions, we proved that the given function is the given relation is reflexive, transitive, but not symmetric. This is the proof of the given problem. Up to this much have to write in the examination. Okay, then you get complete 3 marks. Let's move on the question number 31. Okay, prove that cos inverse of 4 by 5 plus cos inverse of 12 by 3 is equals to cos inverse of 33 divided by 65. We know that the cos formula, that is cos of x plus y is equals to cos x cos y minus sin x sin y. Here the cos function of the form in inverse form. Okay, now I can consider the left hand side, that is cos inverse of 4 divided by 5 is equals to x, and again cos inverse of 12 by 3 is 13 taken as a bar. Now again here I can take cos inverse of 4 by 5 is equals to x. Then taking cos inverse on right side, it becomes cos x is equals to 4 by 5 here. Then in this formula, we can substitute. Okay. Now we have the values, but we don't have the sin x and sin y. So I can find the sin x value here by using, we know that the law of identity. We know that the law of identities, trigonometric laws of identities, that is sin inverse of x, sin square x plus cos square x is equals to 1. Using this law, I can find the sine value, that is sin square x is equals to, taking cos square x on right side, it becomes 1 minus cos square x. So I can simplify here 1 minus, what is the cos x? 4 by 5. Cos square means 4 by 5 whole square. 1 minus 16 divided by 25. So I can take LCM. It becomes 25 minus 16 divided by 25. This is 25 minus 16, 9 by 25. Here sin inverse, sin square x. We want sin x only. That's why taking root here 9 by 25. Square root of 9 by 25 will be here. 9 can be written 3 and 5. This is the value of sin x. Similarly, I can calculate here also. That is cos of cos y is equals to 12 by 13. Same property I can use here. That is sin inverse of sin square y is equals to 1 minus cos square y. 1 minus, what is the cos y? 12 here, 12 square divided by 13. 12 by 13 square. 1 minus 144, 12 square is 144, 13 square is 169. Take the LCM, that is 169 minus 144 divided by 169. 169 minus 144 will be 25 divided by 163. We have sin inverse of sin square of y is equals to 25 by 169. Taking square on this side, then sin y becomes root of 25 divided by 169. Okay, that is 5 by 30. Now we have cos x sin x. Then we have the result cos x sin x cos y and sin y. I can use here. That is cos of x plus y is equals to cos x cos y cos x cos y minus sin x sin y. What is the cos x value? That is 4 by 5 into cos y, that is 12 by 13, minus what is the sin x? 3 by 5 into what is the sin y? 5 by 30. Now 4 by 5, 4 into 12, 12 fours are 48, 48 divided by 13 fives are 65, minus 3 into 5, 3 fives are 15 divided by 65. Denominators are equal, so I can simply subtraction 48 minus 15, it becomes 33. On left hand side we have cos of x plus y taking cos on right side, it becomes x plus y is equals to cos inverse of 33 divided by 65. Again, simply take the values of x and y, substitute here. What is the value of x and y? X can be written as cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equals to cos inverse of 33 divided by 65. This is the proof of the given next one problem. Okay, express first the matrix 3, 5, 1 minus 1 as the sum of symmetric and skew symmetric matrix. Here, first I can take the given matrix as a A. A is equals to 3, 5, 1 minus 1. Here, this is the given matrix. It can be expressed as sum of symmetric and skew symmetric. We know that the result of that is A is equals to 1 by 2 of A plus A transpose plus of 1 by 2 A minus A transpose. Okay, this is the symmetric and this is the skew symmetric. Now, the given matrix can be expressed as sum of symmetric and skew symmetrics. Now, first I can consider here A is equals to, first I can consider the symmetric property. Before that, let A becomes the matrix A containing the elements 3, 5, 1 minus 1. Then the transpose matrix. This is equation number 1. Transpose matrix. What is the values? 3, 5, 1 minus 1. This is the transpose matrix. Now I can take the equation here, that is consider 1 by 2 of A plus A transpose. I can consider this one. Now 1 by 2 of first A matrix containing the elements 3, 5, 1 minus 1 plus 3, 1, 5 minus 1. Now I can add here 1 by 2 remains constant. 3 plus 3, 6. 5 plus 1, 6. 1 plus 5, 6. Here minus 1, it becomes minus 2. Now I can divide each element by 2. We get 3, 3, 3 minus 1. Okay. Again, I can take the another skew symmetric part. That is 1 by 2 of A minus A transpose. Now 1 by 2. What is the A matrix containing the elements? 3, 5, 1 minus 1. Minus of 3, 1, 5 minus 1. Now I can subtract here. Okay. That is 1 by 2 of 3 minus 3. It becomes 0. 5 minus 1. It becomes 4. 1 minus 5. It is minus 4. Here minus 1. Minus into minus plus. Minus 1 plus 1 becomes 0. Okay. Here now I can substitute symmetric and skew symmetric part in equation 1. Then equation 1 becomes that is A is equals to, what is the value of 1 by 2 A plus A transpose here? That is 3 comma 3, 3 minus 1 plus skew symmetric part, that is So I can divide 1 by 2 each. 0, 2 minus 2, 0. Okay, the skew symmetric part is 0, 2 minus 2, 0. Now add these two matrix. 3 plus 0, 3 only. 3 plus 2, 5. 3 minus 2, 1. And minus 1, 0. It is minus 1. Okay. The given matrix A containing same elements 3, 5, 1, minus 1. Here also 3, 5, 1, minus 1. Therefore, A is the matrix of sum of symmetric and sum of symmetric and skew symmetric. Sum of symmetric and skew symmetric. This is the proof. Next one, question number 33. Find dy by dx if x is equals to a into cos theta plus theta into sin theta and y is equals to a into sin theta minus theta into cos theta. This is of the parametric equation. Now, here first consider the parametric equation. First I can take an as a x, that is a into cos theta plus theta into sin theta, and here y is equals to a into sin theta minus theta into cos theta. Okay, I can differentiate with parameter as theta. I can differentiate with parameter theta, that is dx divided by d theta. Here a be a constant, I can take it as a constant. Differentiate with respect to theta. So I can take it separately cos theta plus differentiation of d theta, theta into sin theta. Now a into differentiation of cos theta will be minus sin theta plus, here there are two functions theta and sin theta. Now I can take first function as a constant and differentiate the second function, that is sin theta plus second function as a constant, first function as a differentiation. Okay, here we can use the product rule. U into V rule, because theta is also function and sin theta is also two function. That's why I can use the product rule. Now A into minus sin theta plus theta. Differentiation of sin theta will be cos theta plus sin theta. Differentiation of theta with respect to theta is again 1. Therefore, dx by d theta is equals to minus theta plus theta get cancelled. A into theta cos theta. Again, I can take the differentiation of y with respect to theta. Differentiation of y with respect to theta. Now, dy by d theta is equals to, taken a as a constant. Now, d by d theta of, here also there are two values. I can take separately sin theta minus d by d theta of theta into cos theta. Now, a into differentiation of sin theta will be cos theta minus, here there are two function. Here also I can apply the product rule. That is, first function I have taken constant and differentiation of second function, that is differentiation of cos theta plus taking second function as a constant. First function I can differentiate. Now, A into cos theta minus here theta, differentiation of cos theta will be minus theta, minus into minus becomes plus, that is sin theta plus cos theta. Here differentiation of theta with respect to theta becomes 1. Okay, now A into, here there is a minus, before that here I can take, first simply I can take minus here, then the theta into differentiation of cos theta will be minus. Okay, here there is a minus, cos theta minus into minus, it becomes theta into sin theta. Again there is a minus into plus, it becomes minus cos theta. Now here cos theta get cancelled. A into theta of sin theta. It is dy by d theta. But we want dy by dx. Therefore, dy by d theta divided by dx by d theta. It becomes a into theta cos theta divided by a into theta sin theta. A get cancelled, theta get cancelled. We have sin theta by cos theta by sin theta becomes cot theta. Therefore, dy by dx will be cot theta. Consider this the solution question of number 34. Find the intervals in which the function f of x is equals to x minus 2 cube into x plus 4 cube is. Okay. First, I have take the function f of x is equals to x minus 2 cube and x plus 4 cube. Okay. Differentiate with respect to x. Now, I can differentiate this one. Here I can use the product rule. That is, let's move on the question number 34. Find the intervals in which the function f of x is equals to x minus 2 cube, x plus 4 cube is increasing or decreasing. Okay. Here in this condition, we have to find the intervals. That's why now I can calculate the function and differentiate that function. Based on the differentiation, we can use the find the intervals here. First, I can take the function, that is f of x is equals to x minus 2 cube into x plus 4 cube. I can take differentiate with respect to x. So first, taking f dash of x here. Here x minus 2 and x plus 4 are the two different functions. I can use the product rule. That is, first function as a constant, x minus 2 cube, and differentiate the second function, that is x plus 4 cube, plus taking the second function as a constant, and differentiate the first function, that is x plus 4 cube, and differentiate the first function, that is x minus 2 cube. Now, here taking the differentiation of x plus 4 cube. Here in place of x we have x plus 4. First differentiate x cube, that is 3x square. In place of x we have x plus 4. I can take x plus 4 square. And again differentiate with respect to, in place of x we have x plus 4. That's why again I can take the differentiation. Next, here x plus 4 cube, and differentiating the function, Here 3 into x minus 2 square. In place of x we have x minus 2. That's why I am taking again differentiation x minus 2. Now x minus 2 cube into 3 x plus 4 whole square. Here x plus 4, differentiation of x will be 1 and constant will be 0, plus now x plus 4 whole cube into 3 into x minus 2 whole square. In place of x, differentiation of x we have 1 and 2 will be constant, that is 1. Now simply I can written 3 into x minus 2 cube x plus 4 square plus 3 into x plus 4 whole cube x minus 2 square. Taking some common values here, I can take 3 both side common. Here also x minus 2, here also x minus 2. That is, I can take x minus 2 square as a common and x plus 4 square as a common. In that one, here there is another x minus 2 is there, plus here x plus 4 is there. Okay, that is f dash of x is equals to 3 into x minus 2 whole square x plus 4 whole square. Here x minus 2 plus x, that is 2x, x plus x 2x, minus 2 plus 4, it becomes plus 2. Now for finding the intervals, so I can consider f dash of x is equals to 0. Here I am taking f dash of x is equals to 0. Then 3 into x minus 2 square x plus 4 whole square and 2x plus 2 is equals to 0. Here I can take 3 on right side, it becomes 0. Whatever the values all are 0. Here x minus 2 whole square is equals to 0. X plus 4 whole square is equals to 0 and 2x plus 2 is equals to 0. Now here I am taking x is equals to square becomes 0, x minus 2 is 0, then x is equals to 2. Here also square taking on right side, it becomes 0. X plus 4 is equals to 0, x is equals to minus 4. Here I am taking 2x is equals to minus 2, then x becomes minus 1. There are 3 values of x we have, so I can take the intervals now. Okay, I am roughly taking the line, that is here 0. Okay, here 0, minus 1, minus 2, minus 3, minus 4. Then 1, 2, 3, 4, 5. Okay, now there is a interval. Here x have the 4, minus 4. Then another one point will be minus 1 and here there is a plus. Okay, here now the intervals. Now I can write the intervals here. The function is increasing. The function is increasing. The function is increasing in the interval. In the interval, both having the negative sign. That is minus 4 and minus 1. Again, from here in the interval, I can take close interval. Okay, including these points. Including these points minus 4 to minus 1, and here from minus infinity to minus 4. Okay, the function is increasing. Similarly, the function is decreasing. Similarly, the function is decreasing from in the interval. The function is decreasing in the interval from minus 1 to 2. The function is decreasing in the interval minus 1 comma 2. Again, it is also it is increasing in the interval open interval 2 to infinity. Okay, here this is the open interval. Okay, this is the open interval. Okay, the given function is increasing in the interval minus 4 comma minus 1, minus infinity to minus 4, and 2 to infinity. The function is decreasing in the interval minus 1 comma 2. Okay, let's move on.
Let us consider the question number 35. Find the integration of x divided by x plus 1 into x plus 2 dx. Here the integration of the partial fraction of the type. Here the integration of type. Question number 35. Find integration of x divided by x plus 1 into x plus 2 into dx. Here the integration of the type is partial fraction. Integration by partial fraction. I can take this one as x into x plus 1 into x plus 2. Simply I can return this x divided by x plus 1 and x plus 2 becomes a divided by x plus 1 b divided by x plus 2, because here x plus 1 and x plus 2 are two different forms. Okay, two different equations. That's why I'm taking a divided by x plus 1 and b divided by x plus 2. Here a and b are some constant values. Okay, now I can find the a and b values by using the equations. So I can take the cross multiplication here. It becomes x divided by x plus 1 x plus 2 is equals to here a into x plus 2 plus of b into x plus 1 divided by x plus 1 x plus 4. Here both are get cancelled. Now x is equals to a into x plus 2 plus b into x plus 1. Here we want a and b values. That's why I'm taking put x is equals to minus 2 here in the equation. Then we get b values. 2 is equals to a into minus 2 plus 2 plus b. In place of x we have minus 2 plus 1. Minus 2 is equals to this one get cancelled. b into minus 2 plus 1 minus 1. Here minus 2 is equals to minus b. Then b value becomes 2. Similar manner, put x is equals to minus 1. I can take x here minus 1 in this equation. Then minus 1 is equals to a into minus 1 plus 2 plus b into minus 1 plus 1. This one get cancelled. Minus 1 is equals to a into plus 1. Here a is equals to minus 1. Simply I can substitute a and b values here. That is x divided by x plus 1 x plus 2 is equals to minus 1 divided by x plus 1 plus b value becomes 2 x plus 2. Now taking integration On integration both side. On integration both side, we get x divided by x plus 1, x plus 2 into dx. Here also separately I can take the integration minus 1 divided by x plus 1 into dx plus 2 divided by x plus 2 into dx. Then taking minus 1 common, 1 divided by x plus 1 dx plus 2 into 1 divided by x plus 2 into dx. We know that the formulas of integrations, that is x divided by x plus 1 into x plus 2 into dx. Here minus 1 is constant. We know that the integration of 1 by x will be log x, that is log, in place of x we have x plus 1 plus 2 into, here also integration by 1 by x is log x, that is x plus 2 some constant c. This is the solution of the given problem. Next, let's move on the question number 36. Here this question 36, if vector a, b and c are three vectors such that magnitude of a is 3, magnitude of b is 4 and magnitude of c is 5, and each vector is orthogonal to the sum of the other two vectors, then we have to find the vector a plus vector b plus vector c. Okay, magnitude of vector a plus magnitude of b plus c. Now, by the statement, each vector is orthogonal to some of the other two vectors. Okay, here I can take a is orthogonal to some of the other vectors. That is, orthogonal means perpendicular. So, in the perpendicular means if two vectors are taking dot product, then the dot product will be 0. Okay, this is the definition of orthogonality. By this definition, I can written vector A dot vector B plus vector A dot vector C is equals to 0. Similarly, for second one, vector B perpendicular to vector C plus vector A. Then it becomes dot product vector B dot vector C plus A is equals to 0. Simply I can written vector B dot vector C plus vector B dot vector A is equals to 0. Again for vector C, this is vector E dot plus vector B. Then vector C dot vector A plus vector B. I can simply written C dot A plus vector C dot B becomes 0. Okay, here vector A dot B, here also vector B dot A, both are equal. Simply by these results, I can return 2 times of vector A dot vector B plus vector B dot vector C plus vector C dot vector A is equals to 0. Okay, let's move on the next step. We know that the formula, that is the algebraic formula, a plus b plus c whole square is equals to a square plus b square plus c square plus 2 into ab by bc plus c. Okay, this is the formula for a plus b plus c whole square. Now, I can take here first in a vector form. This formula can be written in vector form, that is Here magnitude of vector A plus vector B plus vector C whole square is magnitude of A square magnitude of B square plus magnitude of C square into vector A plus B dot C plus C dot A. Now taking the values here, magnitude of A is 3, it becomes 3 square. Similarly, magnitude of B is 4 square, 5 square plus 2 is 0. Then 9 plus 16 plus 25. Therefore, magnitude of A plus magnitude of B plus magnitude of C is, taking square root on this side, while taking the sum of 9 plus 16, 25, here 50. Again, 50 can be written as 25 into 2, that is 5 into 2. Therefore, magnitude of vector A plus vector B plus vector C is 5 root 2. This is the solution. Let's move on the question number 37. Here, find the distance between the lines. Okay, here find the distance between the lines. We have 6r is equals to 6i plus 2j plus 2k plus lambda into I minus 2j plus 2k, and another one line r is equals to minus 4i minus k plus mu of 3i minus 2j minus 2k. Okay, now we know that the distance formula. First, I can write the distance formula. For vectors, I can write the distance formula here. That is magnitude of v1 vector cross v2 into vector e2 minus vector a1 divided by magnitude of v1 vector cross v2 vector in whole magnitude. Okay, here I can take the first line as the r1, that is equals to 6i plus 2j plus 2k plus of lambda into I minus 2j plus 2k. Similarly, for second line, r2 is minus 4i minus k mu into 3i 2j minus 2k. Now I can take the values here. That is, first I can take here, this one can be, okay, this one vector is of the form vector a1 plus lambda into this is b. Similarly, I can take here vector a2 plus mu into vector b. Then vector a1 is 6i plus 2j plus 2k. Similarly, a2 is equals to minus 4i k. Again, for b1 is equals to I minus 2j plus 2k. b2 vector is 3i minus 2j 2k. Okay. Now, here, first I can find the vector P2 minus vector E1, that is minus 4 I cap minus K cap, that is minus of again A1 6 I cap plus 2 J cap plus 2 K cap. Here minus 4, then minus 6, that is minus 10 I cap. There is no J element, simply I can write here there is a minus, so I can write minus 2J, here minus K cap plus 2, minus into minus, minus, that is 3 K cap. Then we want cross product of B1 cap B2, that is while taking the cross product there is a indeterminate form IJK, then 1 minus 2, 2 and 3 minus 2 minus 2. Here these B1 values, vector B1 1 minus 2, 2 here, for B2 3 minus 2 minus 2. Okay, now I can calculate the values. I cap into minus 2 in neglecting the first row, first column, that is I into minus 2 into minus 2, that is here neglecting the first row, minus 2 into minus 2, that is first plus 4. Here minus 2 into minus 2 minus, and then again there is a 1 minus plus 4 minus of J. So neglecting second row, 1 into minus 2, 6 minus 2, then 3 to the minus 6 plus again simply K, that is K cap into 1 to the minus 2, 3 to the plus 6. Okay, here this is the value 4I plus 8J plus 4K. Okay, this is the, here sorry, 8 into 8 it becomes 4 into 4 is 8. Now I can find the magnitude of the cross product, that is B1 cross B2, that is root of 8 square plus 8 square plus 4 square, that is 64 plus 64 plus 60. 8 square 64, 64, 64, 128, 128 plus 16, it becomes 14, 144, that is 1. Now I can substitute all the values in a distance formula, that is distance formula is then B1 cross B2. What is that? 8I plus 8J plus 4K into A2 minus A1 minus 10I minus 2J minus 3K divided by 1. Here magnitude of B1 cross B2 is 1. Now here 8 into 10, it becomes minus 80. Here plus into minus, minus 8 to the 16, and plus into minus, minus 4 3 the 12 divided by 12. Then minus 80 plus 10, 90, 96, 106 plus 2, 108 minus 108 divided by 1. 12 ones are 12 nines are. That is minus 9. Mod of 9 becomes 9. Okay. Therefore, the distance between two lines is 9. Two lines is 9. This is the solution. Now, let's move on the question number 38. Here, the bag container 4 red and 4 black balls. Bag 2 container 2 red and 6 balls. Okay. Now, one bag is selected at random and a ball is drawn to be found red. The drawn ball becomes red. What is the probability that bag 1 is selected? Okay. Here, the bag first containing a 4 red ball and 4 black balls. Now, I can written here, let B1 be a event of B1 be a event of bag 1, and again B2 be a event of bag 2. Now we have to find the selected random ball is to be red. Selected ball to be red. Okay. Now again, first there are two bags. There are two bags. The probability of getting both bag containing red balls, the probability of getting red ball is that is probability of bag 1 is equals to probability of bag 2 is 1 by 2. Because there are two bags, both bag containing red ball. Therefore, probability of B1 is equals to probability of B2 is 1 by 2. Now, for bag 1, there are total 8 balls are there. So, there are 8 balls. 4 must be a black ball and 4 be a red ball. Out of 8, 4 is red. That is 4 red plus 4 black. Okay. That is probability is 1 by 2. Similarly, for bag 2, total 8 balls. The probability of getting red ball is 2. That is 1 divided by 4. Because the bag 2 containing 2 red plus 6 black. Okay. This is given. Now, after this total, here total probability for getting red ball is probability of R. Okay, that is probability of R is equals to probability of red ball from bag 1 into probability of bag 1 plus probability of red ball in bag 2. Then probability of bag 2. That is, what is the probability of red ball from bag 1? That is 1 by 2 into probability of B, that is also 1 by 2. Now, probability of getting red ball from bag 2 is here 1 by 4 and probability of B2 is 1 by 2. That is 1 by 2, 1 by 2 becomes 1 by 4 plus 4 into 2, 8, 1 by 8. I can simplify by taking LCM. Here 4 2s are 2, 8 1s are 2 plus 1. It becomes 3 by 8. Total probability of getting red ball from bag 1 and bag 2. But they have to find. Okay, what is the probability of bag 1 is selected? So, probability of bag 1, probability of getting red from bag 1 only, from bag 1. Okay, that is probability of B1 divided by R. Condition is probability of red ball from bag 1 into probability of bag 1. Then what is the total? 3 by 8. Now I can simplify here. Probability of red ball from bag 1 is 1 by 2. Here also 1 by 2 divided by 3 by 8. 1 by 2, 1 by 2 becomes 1 by 4. This is 8 divided by 3. 4 1s are 4 2s are, that is 2 by 3. Probability of getting red ball from bag 1 is 2 by 3. This is the solution of the given problem. Up to this much, the part C will be completed. Okay, let's move on the part D. Okay, here the part D contain mainly 5 marks question. Each 5 marks question, each question carries 5 marks. There are totally 7 questions are there. Out of 7, we have to solve only 4 questions. Okay, now I can take the problem here. First one, state whether the function f from r tends to r defined by f of x is equals to 3 minus 4x is 1 1 onto or bijective. We have to check the 1 1 condition, onto condition. After that, the function is said to be bijective or not, and also justify our answer. Now, first, I can take simply the function from real number to real number is defined by f of x is equals to 3 minus 4x. Now, first condition, we have to check 1 1 condition. Let consider f of x is equals to 3 minus 4x. By the definition or by condition of 1 1, f of x1 is equals to f of x2. What is the f of x1? 3 minus 4x1 is equals to 3 minus 4x2. 3 get cancelled. Here minus 4x1 is equals to minus 4x2. Now, minus 4 get cancelled. x1 is equals to x2. Therefore, for every x1, x2, r belongs to real number r. The function is 1 for all real values of x belongs to real number. Similarly, for second condition, that is onto condition. Okay, here f of x is equals to 1. Now I can take f of x is equals to y, that is 3 minus 4x. Now y is equals to 3 minus 4x. Taking 3 on the left side, it becomes y minus 3 divided minus of 4x. Then y minus 3 minus of 4x. I can take values of x. So I can taking minus 4 on this side, it becomes y minus 3 divided by 4. Taking minus common, it becomes 3 minus y divided by 4, which is belongs to the real number. Therefore, the function is onto. Hence, for all real numbers, hence the function is both 1 and onto. The function is both 1 and onto. Hence, f is bijective. Hence, f is bijective. Then, by the definition of invertible, the function is invertible. Then there exists a inverse. Then there exists a inverse of f. That is f of x is equals to y. Then x is equals to f inverse of y. That is f inverse of y is 3 minus y divided by 4, which is belongs to r. Therefore, the function is bijective. Therefore, the function is bijective. Hence the solution of the given problem. Let's move on the question number 40. Okay, that is if A is equals to 1, 0, 2, 0, 2, 1, 2, 0, 3, containing a matrix. Let A be a matrix of the elements 1, 0, 2, 0, 2, 1, 2, 0, 3. Then we have to prove a cube minus 6a square plus 7a plus 2i is equals to 0. First, let us consider the vector. Let A be a vector containing the elements 1, 0, 2, 0, 2, 1, 2, 0, 1. Now we have to find the A square, that is multiply 1, 0, 2, 0, 2, 1, 2, 0, 1. Okay. Here 1, 0, 2, 0, 2, 1, 2, 0, 1. Taking row by column. Multiply each terms. That is 1 into 1. Here 1 and 0 into 0. That is 0. 2 into 2, 4. First row by first column. 1 into 0, 0. Again 0, 0. Now 1 into 2, 2 plus 0. And here 1 into 2, 2, 0 into 1, 0, 2 into 1, that is, sorry, here 3. Okay, that is 2 into 3 becomes 6. have to remember all the numbers carefully. Okay. Then I can take 0 into 1, 0 plus 0 plus 2. Next, 0 into 0, 0, 2 2s are 4, and 1 into 0, 0. 0 2s are 0, then 2 1s are 2, plus 3 1s are 3. Again, 2 into 1, 2, plus 0, plus 3 2s are 6. Again, 0 plus 0 plus 0. 2 2s are 4, 0 1s are 0, 3 3s are 9. Now I can add all the values. I'm getting 4 plus 1 5, 0 2 plus 6 8, 0 2 4, 2 plus 3 5, 2 plus 6 8, 0 4 plus 3 4 plus 9 30. Okay, 508 245 80 30. Now again I can take the multiplication, that is a into a square, it becomes a cube. Sorry, here a into a, that is a square. Okay, here a cube, that is while taking the values 508 245 80 13 into, can take the matrix A 1 0 2 0 1 and 2 0 3. Now taking multiplication, 5 1s are 5 plus 0 plus 8 2s are 16. Okay, now 5 0 0 0 2s are 0, then 8 0 0. Again 5 2s are 10 plus 0 plus 20 plus 8 3s are 24. 2 1s are 2 plus 4 zeros are 0 plus 5 2s are 10. 2 0 0, then 4 2s are 8, then 5 0 0. Now I can take 2 2s are 4 plus 4 1s are 4 plus 5 3s are 15. Again 8 1s are 8 plus 0 13. Okay, 13 2s are 26. 8 zeros are 0. Then all the entries are zeros here. 8 2s are 16 plus 0 into 1 0. 13 3s are 13. Then I can add here. Then it becomes a cube. A cube is simply adding 16 plus 5, 21, 0. Here 34. Then 12, 8, 23. 26 plus 8, 34, 0 and 55. Now I can substitute all the values here. I can substitute all the values in the equation. A cube minus 6a squared plus 7a plus 2. What is the a cube? 21 0 34, 12 8 23, 34 0 55. Minus of 6 into a square. Here 508 245 80 30 plus 7 into a 102 0, 2, 1 and 2, 0, 3 plus 2 into identity matrix 1, 0, 0, 0, 1, 0, 0, 0. Now I can multiply all the values here. 34, 12, 8, 23, 34, 0, 54. 6 5s are 30, 0, 6 8s are 6 8s are 48, 12, 6 4s are 24, 6 5s are 30, 6 8s are 48, 0 and 72. Plus I can multiply from 7, 7 0 14, 0 14, 7 1s are 7, 7 2s are 14, 0 21 and simply here 1 0 0 0 1 0 0 0. Okay, now I'm taking 21 minus 30 minus 7 here plus 7. Okay, here 21 minus 39. Okay, that is 2 2. 21 minus 30, that is minus 9 plus 7 plus minus 2 plus 2 is 0. 0 0 0. 34 minus 48 minus 18, 34 minus 48, that is minus 14 plus 14, 0, 12 minus 12, 0, 8 minus 24 minus 16, here also 14 plus 2 plus 16 minus 16 getting 0, 23 minus 30 minus 7 plus 7, 0, 34 minus 48 minus 14, here plus 14, 0, 0, 0. Hence the proof of the given problem. Let's move on the next question, that is question number 41. Solve the following system of equation by using the matrix method. Okay, here first I can take the consider. Let us consider the system of linear equation. Let us consider the system of linear equation. Linear equation of form Ax is equals to b. Okay, here A is equal to Ax by b. First, I can write the values. That is 2x plus y minus z is equals to 1. X plus y minus z is equals to 0. X plus 3y plus z is equals to 11. Okay. Now, let us consider the system of linear equation of the form Ax is equals to b. Here from this equation, I can write the vector A containing the values 2, 1, minus 1, 1, 1, minus 1. Here 2, 3 and plus 1. Then b is equals to 1, 0, 11. Then x is equals to x, y, z. Then by using the system of equation from the Ax is equals to b, then x is equals to A inverse of b. Okay, here x is equals to A inverse b. So first I have to find the A inverse now. Okay, what is the formula for A inverse? That is 1 divided by determinant of A into adjoint of A. Okay, First, I can find the determinant of A. That is 2, 1 minus 1, 1, 1 minus 1, 2, 3, 1. Finding the determinant value here. That is 2 into 1 minus 1. 1 into 1, 1. 3 minus 1, minus 3. Here 1, 3. That is plus. Minus 1 into, I can solve by using the column. 1. Neglecting the second row, first column 1 into 1. 1, 3 into minus 1, minus 3. Here there is a 1. Minus, it becomes plus. Again plus 2. Then 1 into minus 1, minus 1. 1 into minus 1. Here minus 1 plus 1. Okay. That is 3 plus 1, 4. 4 to 8 minus 3 plus 1, 4. 4 minus 4 into minus 1. That is minus 4 plus 0. Therefore, 8 minus 4 is 4. I can write here the determinant of A is 4, not equals to 0. Determinant value is not equals to 0. Therefore, A is non-similar matrix. A is non-similar matrix. Now we can find the adjoint of A. Okay. Now we can find the adjoint of A. So first I can write the values for 2. Okay. That is, this one is here A1, A12, A13, A21, A22, A23, A31, A32, and A32. Okay. Here the for first element A11 is neglecting first row, first column, that is 1 minus 1, 3 comma 1. A22, that is okay 1. For this one, neglecting the first column, the second column, first row 1 minus 1, 2 minus 2 comma 1. Here is 2. Okay. Now A23. Then A11, A12. Here A13. A21, that is A22, A23. I can write by row wise. First, I can consider first one A11, A12, A13, A21, A22, A23. Again here, I can write A31, A32, and A1, A32. A31 for this element 1, 1, 2, 3. So for this element, have to neglect these 1 minus 1, 3 comma 1. For the middle one, 2 minus 1, 2, 1. For this element, 2, 1, 2, 3. Okay. For the third element, 1 minus 1, 1 minus 1. For this element, 2, 1, 2, 3. 2, 1, 2, 3. For the last element, 2, 1, 1, 1. Okay, I can return here. Now, for finding the values. Okay, here 1 into 1, 1. 3 into minus 1, that is minus 3. Here plus 3, that is 4. And 1 into 1, 1 plus 2, it is 3. 1 3 is a 3, minus 2 is equals to 1. Again 1 1 is a 1, 1 into minus 3, that is 3 becomes 4. 2 1 is a 2 1 is a 2, 2 into 1, that is plus 2. 2 into 3, 6, minus 2 1 is a 2. 2 2 is 4, 6 minus 2, 4. Again 1 into minus 1, minus 1 plus 1. Here 2 into 3, that is 6 minus 2. 2 into 1, 2 minus 1. Minus 1 is 0, 4 and 2 minus 1, that is 1. Now, these are the minors of the given factors. Now, I can simply taking the cofactors. Okay, I am taking the cofactor for this element, that is multiplying plus minus for this one and plus minus plus minus plus minus plus. Okay, then we get the cofactors. For this one, we have get the cofactor. Simply change the sign value. That is 4 is minus 3 and 1 minus 4 plus 4, here minus 4 and 0 minus 4 plus 1. Now, directly I am writing adjoint. Directly I am writing the adjoint, that is adjoint of A. That is, definition of adjoint means transpose of the cofactor of given matrix A. So I can simply written in this form because I can written in a row form. Okay, here I can simply directly written in a column. That is the transpose. 4 minus 3, 1 minus 4, 4 minus 4, again 0, 4, 1. This is the adjacent. We want A inverse. Okay, we want A inverse. Therefore, A inverse is equals to 1 by determinant is 4 into 4 minus 4, 0 minus 3, 4 minus 4, 1 minus 4 into 1. But we want to find the values of x. I can find here only, that is x is equals to A inverse into B. What is the value of A inverse? 1 by 4 I am taking here, then 4 minus 4, 0 minus 3, 4 minus 4, 1 here, 1 I can take 1 minus 4 and 1. The value of B 1 0 11. So I can multiply row by column, that is 1 by 4 into 1 4. Here minus 4 into 0 minus 0, 0 into 11, it becomes 0. Minus 3 into 1 minus 3, 4 into 0, that is 0, minus 4 into 11, minus 44. 1 into 1, that is 1, minus 4 into 0, that is 0, 1 into 11, 11. Then which 1 divided by 4 into 4, here minus 44, and 11 plus 1, that is 12. Here I think this is, I will check the values. 1 into 1, 1, 2 into minus 1, that is minus 2, here minus 1 is plus 4. I can take ones, that is neglecting these 1 into 1, 2 into minus 1. The second row. Okay, here divide by each term by 4, then that is 1 minus 11, 3. Therefore, x is equals to 1, y is equals to minus 11, and z is equals to 3. This is the solution of the given problem. Let's move on the question number 42. Okay, here if y is equals to 3 into cos of log x plus 4 into sine of log x, we have to prove that x square into dx square divided by dy square plus x into dy by dx plus y is equals to 0. Okay, first have to consider the equation 1. Y is equals to 3 into cos of log x plus 4 into sine of log x. Now, have to differentiate with respect to x. Differentiate with respect to x. Then it is dy by dx is equals to 3 becomes constant. Differentiation of cos of log x. Differentiation of cos x will be sin x, that is sine of log x. Again, differentiation in place of x we have log x. That's why I can take again log x plus 4 into differentiation of sin x will be minus cos x. In place of x we have log x. That's why I'm taking again differentiation of log x. Then 3 into sine of log x. Differentiation of log x will be 1 by x. Here plus into minus, minus 4 cos of log x into 1 by x. Taking 1 by x as a common, that is 3 sine of log x minus 4 cos of log x. Taking 1 by x on left side, it becomes multiplication. X into dy by dx is equals to 3 into sine of log x minus 4 into cos of log x. Now, I can take again differentiation. Now, I can take again differentiation, that is, here I can take differentiation with respect to x. Here there are two functions. I can apply UB rule. First function constant, differentiation of second function, that is d square y by dx plus here dy by dx. Second function constant, again differentiation of x will be y, that is equals to 3. Differentiation of sine function will be cos of log x, and again in place of x will be log x. So I can take again differentiation of log x minus 4 into differentiation of cos x will be again sin x that is minus sine of log x. Differentiation of log x. Now, I can take here, that is x. Here, x into d square y by dx square plus dy by dx is equals to 3 into log of, 3 into cos of log x into 1 by x minus into minus plus, that is sine of log x divided by x. So again I can take x as a common and taking here, that is square d square by dx square plus x into dy by dx is equals to 3 into cos of log x. Here minus plus sine of log x. Okay, taking here, this is again y, x square d square y by dx square plus x into dy by dx is equals to minus y. Taking minus y on right side, it becomes plus, that is x square d square y by dx square plus x into dy by dx plus y equals to 0. This is the solution of the given problem. Let's move on the question number 43. Find the integral of 1 divided by root of a square minus x square with respect to x and evaluate 1 divided by root of 7 square minus x square. First, I can consider the integral part of 1 divided by root of a square minus x square into dx. We already know the formula for integration of root a square minus x square dx. This is the standard formula, that is sine inverse of x by a plus. Therefore, now I can take here, replace, put x is equals to a sine theta. X is equals to a sine theta in this equation. That is integration of 1 divided by root of a square, that a square minus, here in place of x we have to take the a sine theta, that is a square sine square theta into d theta. Okay, now I can differentiation with respect to theta, that is x is dx is equals to differentiation of a will be constant. Differentiation of sine theta becomes cos theta into d theta. Okay, here in place of dx, replace x. Again, in place of dx, we can write a into cos theta. Now, integration of a cos theta into d theta divided by taking a square as a common, that is a square into 1 minus sine square theta. Again here taking a square as a common outside, cos theta divided by a into root of 1 minus sin square theta into d theta. That is, here a get cancelled. Cos theta divided by 1 minus sin square theta will be cos square theta. That is cos square theta. Root get cancelled into d theta. That is integration of cos theta divided by cos theta into d theta. This one get cancelled. I can take integration of 1 divided by root of a square minus x square is equals to integration of 1 into d theta. What is the integration of 1 with respect to theta becomes? Theta, we know that here x is equals to a into sine theta. So we want theta, then it is, I can take here, simplify x is equals to a sine theta here, x is equals to a sine theta. We want theta, that's why I'm taking a here, x by a is equals to sine theta. That's why we want theta only. I can take a sine here, that is sine inverse of x by a is equals to theta. Therefore, I can simply substitute here some constant c. That is sine inverse of x by a plus some constant c. Therefore, integration of 1 divided by root of a square minus x square dx is sine inverse of x by a. Okay, now have to evaluate. Therefore, integration of 1 divided by root of 7 square minus x square into dx. In the above formula, we can substitute the values. That is sine inverse of, here x, in place of a we have 7, x by 7 plus some constant c. This is the solution of the given problem. Let's move on the next question. Solve the differential equation dy by dx plus y sec x is equals to tan x. Okay, here this is the differential equation dy by dx plus y is equals to y sec x is equals to tan x. Now I can consider here, let consider the differential equation dy by dx plus y sec x is equals to tan x. Sec x is equals to tan x. Then I can use here the differential equation of the form. The differential equation of the form dy by dx plus py is equals to q. The differential equation of the form py is equals to q. We have to use the formula. Now we can find the integrating factor. That is e to the power of p into dx. Integrating factor e to the power p into dx. That is integration of e to the power p. What is the p here? Sec x. Sec x into dx. What is the integration of sec x? Yeah, integration of sec x baby. Integration of sec x dx, that is log of e to the power log of sec x plus tan x, log of sec x plus tan x plus some constant c. Okay, now
e to the power log x will be again sec x plus tan x. Now, the required solution is the required solution is that is integrating y into integrating factor is equals to integration of q into integrating factor dx plus some constant c. Here I can take y. What is the integrating factor? That is sec x plus tan x is equals to integration of q. That is here again q is tan x into sec x plus tan x into dx. Then y is equals to sec x plus tan x is equals to taking multiplication integration of tan x into sec x dx plus integration of tan square x dx. Now again here integration of tan square x here tan x into sec x plus integration of tan x plus sec x is tan x sec x plus dx. Again I can take tan x into sec x. Then tan square x can be written as plus sec square x minus 1 by using the identity, that is 1 plus tan square x is equals to sec square x. By that property we have applied here into x, that is tan x into sec x plus sec square x minus, while taking the integration, this is sec x plus tan x. We know that integration of tan x into sec x will be sec x plus tan x. Integration of sec square x is minus. Okay, here integration of tan x sec x plus sec square x is tan x plus sec x minus integration of minus 1 becomes minus x. Sorry, I can take separately. Okay, I can take separately. Don't confuse here. Here integration of tan square, there is no formula for tan square x. So I can take here tan square x can be written in a simplified sec square x minus. Now I can integrate. Integration of tan x into sec x becomes integration of tan x into sec x becomes tan x plus here tan x into sec x, here tan x. Again integration of sec square x is sec x. Integration of minus 1 becomes x plus some constant c. Now the required solution is here the required solution is tan x plus sec x minus x plus c. Here the required solution
y is equals to tan x plus sec x minus x plus some constant c. Let's move on to question number 45. Differential equation dy by dx plus y sec x is equals to tan x. Okay. Here I am taking the values here. Okay. Now I can take the equation, that is dy by dx plus y sec x is equals to tan x. Okay. The differential equation of the form, that is dy by dx plus y into p is equals to q. The differential equation of the form p into y plus q. Now here p is equals to sec x and q is equals to tan x. Now directly I am going to find the integrating factor, that is e to the power p into dx. Here e to the power p, that is integration of sec x dx. Now integration of sec x will be log of sec x plus tan x. Okay. E to the power log of sec x plus tan x becomes sec x plus tan x. Okay. Now, by using the integrating factor, the required solution is y into integrating factor is equals to integration of q into integrating factor into dx plus some constant. Now I can written y here integrating factor, that is sec x plus tan x. Again, what is the q? That is tan x. Integrating factor sec x plus tan x into dx with some constant c. Now I can multiply tan x on inside, that is tan x into sec x plus tan square x dx plus some constant c. Okay. Here we know that the integration of tan x sec x. Okay. Then again integration of tan square x, there is no formula. That's why I'm taking here tan x sec x dx plus integration of tan square x dx plus some constant c. I can take integration of tan x sec x dx. In place of tan, there is no formula for tan square x. That's why I'm taking the formula, that is sec square x minus 1. The formula is taken from the identities of trigonometry, that is 1 plus tan square x is equals to sec square x. Okay. Now I can replace tan square x by sec square x minus 1 into dx plus some constant c. Now I can take integration separately, that is y into sec x plus tan x is equals to, here integration of tan x into sec x will be sec x again plus integration of sec square x, that is tan x. Here minus 1 integration of constant will be x plus some constant c. Now y is equals to, I can take x plus tan x on right side, it becomes sec x plus tan x minus x divided by sec x plus tan x, some constants. This is the solution of the required differential equation. Next, let us move on the next question. Find the area of circle. Find the area of circle of the equation x square plus y square is equals to a square by the method of integration. Okay. Now, I can take the equation of circle, that is x square plus y square is equals to a square. Now I can consider the circle containing the four quadrants. Okay, here I can take the circle and taking one part and multiply from this point. I can take the integration. Here there is a point from 0 to, there is a unit value a. This is a. Now the area, okay, area of circle on y-axis, area of circle on y-axis. Here this one I am taking a image. Area of circle on y-axis, the values taken from y0 to y a. The limit I have taken 0 to a. The starting point 0 and the end point is a. Area is equals to 0 to y into dx. Okay, here 0 to 2. What is the y? I can solve the equation x square plus y square is equals to a square. We want y, that's why y square is equals to a square minus x square. I want y only, that's why a square minus x square. So I can simply substitute y the values a square minus x square into dx. Here, we know the formula of integration. Integration of root a square minus x square will be x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a plus some constants. This is the formula of integration a square minus x square. Okay. Here I can apply the lower limit and upper limit. Okay. Wherever x we have to apply once as a 2, that is upper limit. That is 2 by 2 into root of 2 square a square minus 2 square. That is, sorry, here not 0 to 2. This is 0 to a. The limit 0 to a. I can take here a square plus a square by 2 sine inverse of, in place of x I can take a by a. Again there is here there is no constant because there is a some definite values. Okay. Now while taking the upper limit, again wherever x minus of, taking lower, wherever x I have to take the 0. 0 by 2 root of a square minus 0 plus 0 by 2 sine inverse of 0 by a. Now, here 2 by 2 is 0. A square minus a square, it becomes 0. Now, a square divided by 2, sine inverse of, okay, here sine inverse of 1. Sine inverse of a by a is 1 minus 4, the value becomes 0. That is 0. That is a square by 2. Sine inverse of 1 will be, sine inverse of 1 will be, what is that? What is the value of sine inverse 1? That is pi. Sine inverse of 1 will be pi. Therefore, pi is a square by pi. Area of circle will be pi by 2 a square units.
Consider the party session. Answer the following questions. Question number 46. Maximize and minimize z is equals to 3x plus 9y subject to the constraints x plus 3y less than or is equals to 60, x plus y greater than or is equals to 10, x is less than y, x is greater than 0, y is greater than 0 by using the graphical method. First, I can considering the equations. Here z is equals to 3x plus 9y. Similarly, subject to the constraints, the values x plus 3y less than or is equals to 60, x plus y is greater than or is equals to 10, x is less than y, and x is greater than or is equals to 0, y is greater than or is equals to 0. I can take the values for these three equations, that is x plus 3y less than 60, x plus y is greater than or equals to 10, and x is less than y. Now I can take the values of x and y by using equation 1 by 1. Here x plus 3y is equals to 60. Now I want the values of x and y. So I can take here x and y. When I take x is equals to 0 in this equation, the y value becomes 20. Similarly, I can take y is equals to 0, x value becomes 60. Okay. Now, let's move on the next one equation. That is x plus y is greater than or is equals to 10. Okay. Now, I can plot a graph for this. That is x comma y. Here I can take x is 0, y becomes 10, y is 0, x becomes 10. Similarly, I can considering the third equation, x is less than y. It means x minus y is less than or is equals to 0. X minus y is less than or is equals to 0. So I can take the values here. X is x and y. X is 0. Then y becomes x is 0, then y becomes 0. Again, x is 1, y is 1. Okay, the values are going like this one. Now, I can take the graph for these values. Now, simply I can take the graph here. Here, roughly, I can take graph. Sorry. Here, I can draw a graph. I can draw a graph. You have to take the graph in a graph. Simply, I can take the graph roughly. Here 10, 20, 30. Up to this much is enough because our y values 10, 20 only. Here 10, 20, 30, 40, 50, 60. This is x-axis, this is y-axis. Now I can plot a diagram. Okay. For first graph, I can represent here first equation. At x is equals to 0. This is the origin. At x is equals to 0, y becomes 20. And y is 0. Okay. Let's take the values. Here x is 0, then y becomes 20. When y is 0, x is 60. Okay. I can draw a line for joining these 2 points. Okay. Now let us take the equation number 2. X is 10. At x is equals to 0, y becomes 10. Similarly, y is 0, x is 10. This representation. For the third one equation, the graph is of the form. Okay. Here, I can take these 2 points. Now, here shading region. X plus 3y is less than 60. It means we have to shade on this side. This is the shaded region of the first one graph. Okay. Now, for the second one equation, the shaded region is this one. Okay. For the third one graph, the common shaded region is in these. This is the common shaded region. Therefore, the corner points are here. I can take the corner points A, B, and here there is a region point C and D. Here A represent the x is 0, y becomes 20. When we take in a graph, the points are B containing the points 15, 15. You have to plot the graph in a graph sheet. Then you have directly taking the values 15 and 15 you getting. Again here 5, 5. This one result is 5, 5 and this one point is x is 0, y becomes 10. The visible region is the visible region. The visible region of the graph is A, B, C, D, A. This is the visible region. I can take all the corner points here. That is corner points. The equation of z. Z is equals to 3x plus 9y. Z is equals to 3x plus 9y. What are the corner points? A. That is 0, 20. B is 15, 15. And C point is 5, 5. D is 0, 10. Now I can find the values here. Put values in equation Z. Z is equals to 3 into 0 plus 9 into 20. It is 180. Because 3 into 0, 0. 9 to 18, 180. Similarly for Z is equals to 3 into 15 plus 9 into 15. It is 180. Because 15 threes are 45. 15 nines are 135. 135 plus 145, it becomes 180. Now, Z is equals to 5, 5. 3 5s are plus 9 5s are. Here, 3 5s are 15. 9 5s are 45. It becomes 60. Again, for the last point, Z is equals to 3 into 0 plus 9 into 10. This is 19. By these corner points, these two are maximum. These two are maximum and this one is minimum. Therefore, by the graphical representation, by using the graphical graphical method, the maximum value, the maximum value, the maximum value of the optimal solution is 180 at corner points at or at corner points A and B, and also for minimum value of the optimal solution. For the optimal solution is 60 at corner point C. This is the solution of the integral part. Here, this is also question number 46. You can write the graphical representation of LPP, or otherwise you have to solve the integral parts. In these two questions, you can solve any one, the question containing 6 marks. Okay. Now, I can take the integral part. Let a to b f of x dx. It is equals to integration of a to b f of a plus b minus x into dx. Now, first I am taking the LHS part, that is integration of a to b f of a plus b minus x into dx. Okay, here put a plus b minus x is equals to t. Again, taking differentiation, it is minus dx is equals to dt. Now, here there is a lower limit and upper limit. Here the limits also changes. That's why take x is equals to lower limit as a, that is a plus b minus a is equals to t. A get cancelled. The limit changes to b. Similarly, x is equals to b. A plus b minus b is equals to t. Here changes, the limit value becomes a. Okay. Here when we substitute the limits, we get the new limit point. Okay. Now I can take the LHS part, substitute all the values, whatever changes in the LHS part. The limit points in place of a, we can write b, here a. Okay. Again, f of t is equals to, here f of, in place of a plus b minus x, I can take t. Here dx is minus dt. That is minus dt. Now I can take the negative minus here, that is b2a f of t into dt. We know the property. Okay. We know the property, integration of a to b f of t dt can be written of negative. The limits are changes, that is b to a f of t into dt. Okay. By using this property, I can write the values here, that is limits are changes a to b f of t into dt. Again, I can use the another one property, that is integration of a to b f of x dx can be written as integration of a to b f of t into dt. I can use the same property here, that is a to b f of x into dx. Therefore, by using the property, I can erase because I want some place here. By that property, by that property, the this is the LHS part. Hence the proof of the property. Now, based on property, we can solve the problem here. Then first, I can take the integral part. I is equals to pi by 6 to pi by 3. What is the integral part? 1 divided by 1 plus root of tan x. We know that tan x can be written as sin x divided by cos x. So I can directly write pi by 6 to pi by 3, 1 divided by 1 plus root of sin x divided by root of cos x. Again, I can multiply root of cos x here by the rule and directly written pi by 6 to pi by 3 root of cos x divided by root of cos x plus root of sin x into dx. This is taking equation number 1. Now, apply the property. Apply the property, that is integration of a to b f of x dx is equals to a to b f of a plus b minus t into x into dx. I can change x by a plus b minus x here. That is integral of limits are same. Here this is pi by 3, pi by 6 to pi by 3. Okay. Now I can take the property here. That is, while taking the property, root of root of cos x. Okay. Here root of cos x. Here the limit points are changes here. A to b here by using the property, that is cos of pi by 6. We take pi by 6 and a value becomes lower limit, b is the upper limit. I can apply here, that is cos of pi by 6 plus pi by 3 minus x in plus root of sine pi by 6 plus pi by 3 minus x. Here I can use the property. By that property, the integrals are by that property the integrals are changes. Okay. By that property, here I is equals to pi by 3 to pi by 6. That is, the values will be pi by 3 to pi by 6. 5 by 6 plus pi by 3. I can take here pi by 3 plus pi by 6 by taking the LCM 6. Here 3 2s are 6 1s are 2 pi plus 5. It is 3 pi by 6. 3 1s are 3 2s are. We have root of cos pi by 2 divided minus x. Again here cos of pi by 2 minus x plus root of sine pi by 2 minus x. By the property, we can say I is equals to pi by 6 to pi by 3. By the property of the cos pi by 2 minus x is sine. Sine x divided by cos x plus sin x. Here, that's it. Equation number 2. Add equation 1 and 2. Add equation 1 and 2. Then 2I is equals to integration. I can take the negative integrals. Here I can taking the minus, that is pi by 3 to pi by 6 root of sin x divided by root of cos x plus root of sin x. Again, similarly, here also I am taking the upper and lower limits. Okay, by that property, it become changes. Pi by 6, it is cos x divided by cos x plus root of sin x into dx. Both denominators are same. That's why I can write once. That is root of cos x plus root of sin x. Denominators are same. Then numerator have to be added. Root of sin x plus root of cos x into dx. Here both are equal. Cancel it. 2I is equals to 1 into integration of pi by 3 pi by 6 dx. Integration of 1 with respect to dx is x. 2I is equals to 1 into dx. Pi by 6 pi by 3. Now first I can substitute the upper limit minus lower limit. Pi by 6 minus pi by 3. This is pi by 6. Now therefore this implies 2I is equals to pi by 6, but we want integral part, that is I is equals to pi by 12. This is the solution of the given problem. Now we can move the next one question. Question number 46. This is also one of the important problem. Okay, that is find the value of k so that the function. Here I can take the function f of x is equals to kx plus 1 if x is less than or is equals to 5, 3x minus 5 if x is greater than 5. Now I can take the roughly the points. Here at x is equals to 5, the value is kx plus 1. At right side, it is x is less than or is equals to 1, that is 3x minus 5. The left value is kx plus 1. Now I can take here. We know that the function is said to be a continuous. The function is said to be a continuous. The function is said to be a continuous if left hand limit, that is limit x tends to 5 minus f of x is equals to the main function limit x tends to 5 f of x, and the right hand limit x tends to 5 plus f of x are equal. They said the function is continuous at point x is equals to 5. So I can directly find the limit points. The left hand limit is, here the left hand limit is limit x tends to 5 minus f of x. Limit x tends to 5 minus, what is the f of x? Kx plus 5. Now I can substitute the values, that is 5k plus 1. Here the main function is also same, not necessarily find. Then RHS part, limit x tends to 5u plus f of x. This is limit x tends to 5u plus, what is the f of x? 3x minus 5. Now I can take x as a 5, 3 into 5u minus 5. This is 15 minus 5 is 10. By the definition of continuous function, the left hand limit, right hand limit functions are equal. Therefore, 5uk plus 1 is equals to 10. 5uk is equals to 10 minus 1. 5uk is equals to 9. The k value becomes 9 by 5. This is the solution of the given problem. You can solve the continuous function. Otherwise, the 47 question will be based on the matrices. Okay. Now, let us move on this problem. First, have to take we know that the inverse. Okay. Let A inverse means 1 divided by determinant of A into adjoint of A. Okay. Determinant of A is equals to adjoint of A. Here, first I can take LHS part, that is AB inverse. Okay, that is 1 divided by determinant of AB into adjoint of AB. First, I can calculate AB here. That is 2, 3, 1 minus 4. And 1 minus 2 minus 3. Taking multiplication row by column. This is 2 into 1, 2, 3 into 3, minus 3. 2 into minus 2, minus 4, 3 into 1, 3. 1 into 1, 1, minus into minus, that is plus 4 3 is a 12. Next, 1 into minus 2 here minus, that is 2 minus 9 minus 7 minus 1, 13 and minus 16. This is AB. We want adjoint of AB, that is here have to change the values. Okay. Adjoint of AB means the values will be changes. Here minus 6, minus 7. I can change the sign. This is plus 1, minus 13. This is the adjoint of AB. Therefore, AB inverse is equals to, we want the determinant of AB, that is, I can find 7 6 are 42 plus 13 into 1, 30. It is 55. Okay. 1 divided by 55 into adjoint, that is minus 6, 1, minus 13, minus 7. This is the AB inverse. Now, find the B inverse and A inverse. I can take the B inverse first. That is 1 divided by determinant of B into adjoint of B. Here, determinant of B is, that is 1 minus 2 minus 3, 1. 1 into 1, 1. 3 into 2, 6. Here minus 6, it becomes minus 5. Then adjoint of B, that is changing the values 1, 1. The sign will be changes. Okay. Therefore, B inverse is 1 divided by minus 5, 1, 2, 3, 1. Similarly, I can take A inverse, that is 1 by determinant of A into adjoint of A. What is the determinant of A? Here 2, 3, 1 minus 4. 2 fours are 8 minus 8, 3 ones are 3 minus 3. It is minus 11. Okay. Now adjoint of A, that is minus 4 to here minus 1 and minus 3. Then A inverse is 1 divided by minus 11 into 4 minus 3 minus 1, 2. Therefore, the RHS part, that is B inverse into A inverse, I can put here B inverse is 1 divided by minus 5, 1, 2, 3, 1 and 1 divided by minus 11. Here 4 minus 3 minus 1, 2. Minus 5 into minus 11, it is 1 by 55. And again 1 into 4, 4. 2 into minus 1, minus 2. 1 into minus 3, it becomes minus 3. 2 2 is 4. 3 4 is 12. And 1 into minus 1, minus 1. 3 into minus 3, minus 3. 1 2 is 2. Therefore, 1 divided by 55, 4 minus 2, it becomes 2. Sorry, here somewhere I done mistake. 2. This is 1. Okay. Here minus, I can take the minus here. This one is minus 7. Here there is a minus is missing. This is minus 4 and minus 2. Then minus 4 minus 2 becomes minus 6. Here minus 13 and minus 3 plus 4, it becomes 4. Therefore, 1 divided by 55 minus 6, 1 minus 13 minus 7. This is B inverse into A inverse. This is equation number 1 and 2. From 1 and 2, from 1 and 2, LHS equals to RHS. Up to this much, the question paper will be completed. So, all the best for your annual exam. Have to by this model question, minimum around 40 to 50 marks will be asked for your examination. Okay. Thank you. Thank you for watching my channel. If you have any doubts, send me in a comment box. Please do share, subscribe and like my channel. Give me an opportunity to share my experience with you all. Thank you everyone.